We often look at the night sky and feel a deep sense of curiosity about the macrocosmos, wondering what secrets are hidden across the light years of the Andromeda galaxy. We scale that wonder down to the depths of our own oceans, where alien ecosystems thrive in the complex architecture of a coral reef. Or we marvel at the ancient geological forces required to push massive, snow-capped mountain ranges into the clouds. But the scale of mystery changes abruptly when taking notes and your pen suddenly stops writing. You scribble harder, but the paper stays blank. Fixing this minor daily frustration requires the exact same mental engine an astrophysicist uses to probe the stars. We frequently associate science with a static collection of facts, a thick textbook full of absolute answers and sterile laboratories. In practice, science describes a specific behavior. It is a framework for thinking, observing, and doing. When you refuse to just throw that broken pen away and instead start investigating why it failed, you are already acting as a scientist. Your brain solves this using a specific sequence. First, you note the ink has stopped flowing. That is the initial observation. This observation leads to a question: why did my pen stop writing? You follow that question with an educated guess or a hypothesis. You might assume the ink refill is simply empty. To find out, you test that guess. You unscrew the barrel and check the ink tube. Finally, you analyze the results. If the tube is full, your hypothesis failed, forcing you to make a new guess. Perhaps the ink is dried up, and the cycle begins again. This repeatable loop of guessing, testing, and refining is the universal tool for solving any problem in the universe. A bicycle mechanic uses this logic to find an invisible leak, testing their guesses by watching for air bubbles in a basin of water. In the kitchen, a cook investigates the reactions within a dish, like dal or bati, adjusting the heat and ingredients to see how the flavors transform. These mechanics and cooks are utilizing the same analytical rigor found in a professional research laboratory. We can apply this five-step loop to the natural world to understand how a tiny seed manages to transform soil and water into a complex living organism. We scale the method up to track planetary weather systems, observing how water changes form to drive global cycles. By tracking cause and effect, we see how solar heat evaporates ocean water, forming clouds that fall back as rain. Whether the subject is the material of a plastic ruler or a massive storm system, the underlying engine of discovery remains identical. Because there is always more to observe, science is like a giant infinite jigsaw puzzle. Every time we place a piece of knowledge down, it reveals new edges. Each discovery creates an immediate need for even more answers. This is a collaborative effort. Scientists across the world share their pieces, building upon each other's failed guesses and successful tests. Science is not a final destination, but a continuous journey of pushing back the boundaries of the unknown. The title of scientist is not a status symbol reserved for people in labs. It belongs to anyone who chooses to observe their surroundings with intent. Navigating this world wisely requires an unrelenting habit of being a wise person. Raw curiosity provides the momentum needed to explore the mysteries of the universe.